I think firstly, I just want to commend everybody for being here this morning after a late night like last night. It's so amazing to see so many people here. Um, yeah, so uh, I've got the privilege of talking a bit about the story, the good news about Tennant mining and the Tennant Creek goldfield. And I have to make a note just from the start that although this presentation is on a Pan-African template, it's not about the Pan-African acquisition or so. It's all about Tennant mining and what the team has done and how they took certain steps to leapfrog and fast track the project. And that's the title of this presentation as well is, from concept to gold in roughly about 4 years. How do you do that? That's unheard of in the industry. And then also just on the title slide, you'll see, the Pan-African sort of motto for this year was expanding horizons. And I think we've really done so, with the name of Pan-African, and we ventured into Australia. And we've been heartily welcomed here. And thank you for everybody for doing that. We haven't felt like outsiders, actually. Just a quick disclaimer and forward-looking statement, as everybody has done. I don't think I'll mention anything market sensitive, but you're welcome to read through that. And then just acknowledgement of the country. Obviously, the elders and people of the Warramungu and Walmampa, where we're actually mining in or going to mine in the near future. We're honored to be on that ground and we're honored to work with the team there. Just a quick outline of the presentation. My presentation is not so much geologically orientated, so I'm very happy that the previous presentations was explaining quite a lot on it. So I'll go through a bit of background, then just a quick touch on the geology, and then sort of what set the project apart. So we look at the crown pillar failure, sort of history, what happened over time to bring it to where it is today. And then looking at some of the exploration the guys are doing on site, mainly brownfields. And then just a quick update on the project construction, where we are, and then some future work that we're looking forward to doing in the next year or so. So as a background, you know, the Tennant Creek area has rich history in mining, as you can see with a headgear of Warrego in the background there. And as everybody has talked about, um, the deposit was discovered quite early on, 1930s. And this is just a quick view of where these projects are located. And I think on the left-hand side, I'll just mention one last point on Pan-African, where we're located. We've got 4 underground mines in South Africa, 3 surface operations in South Africa. We still hold about 1,100 square kilometers, highly prospective exploration concessions in Republic of Sudan, and then also now in Northern Territory. Yeah, so as I said, this field was discovered by Jack Noble and Bill Weaver in the early 1930s, and quite soon thereafter, mining commenced, mainly at the Nobles, and then soon thereafter by various other mining centers. Then, following that, you know, the next 30 or so years, the operations changed hands through owners, and in 1967, the crown pillar of the underground gold mine from Nobles collapsed. And subsequently, the owner at the time, Australian Development, they excavated that failure zone, uh, part of the collapse, a vehicle, the mill, an office, all collapsed into the zone. They excavated that failed material, stockpiled it next to the plant at that stage, rebuilt the milling circuit, and actually continued mining of the Nobles as an open cast mine up until 1985 when it closed down. And up until that time, I think, if I'm correct, if my sources are correct, it was actually the largest open cast mine in Australia. So this crown pillar stockpile material um, obviously now contains diluted ore and hanging wall and footwall lithologies. And apart from a couple of tons that was processed just after the mill commenced, while the pit pushback was created, it has remained on surface untouched since 1967. So, post the cessation of mining, there was a lot of explorers in the field trying to make something. But as everybody has talked about, and as Tennant Consolidated Mining or TCMG's name suggests, we need a consolidation of this area to really get economies of scale. We've heard that these deposits are narrow not a lot of alteration around it, and they're small. So to get any economies of scale, you need to consolidate and work with people. So in 2021, TCMV came up with this idea of this consolidation and started with the project. They acquired the rights to Nobles, Juno, and Warrego, and then also just later on signed a joint venture with Emerson, um, which has really set this project apart. You know, having access to about 1,700 square kilometers in prospective ground in Tennant Creek, that really just shows the consolidation of the field. Then, when was it? About May 2024, Tennant Mining commenced with the construction of the new gold plant at Nobles. And this, again, you know, going with the whole consolidation and just economies of scale, will be the largest gold plant ever to have been constructed in this field, with a capacity of about 840,000 tons a year. And then that was followed with a quick drilling program and evaluation of the Crown Pillar stockpile to come up with a JORC compliant resource of about 1.3 million tons at 1.5 grams per ton, lying on the surface for the last 50 years. So just quick slide on the geology of nobles. We all know that these deposits are contained within the Warramunga Formation, and it's associated with the ironstones. The geology is characterized, sorry, my South African English is running out. The geology is characterized by a major period of deformation, which formed east-west trending and subhorizontal faults and faulting. Reverse faulting and thrusting occurred concurrently with the shearing in its area as well as fault creation. Triclip movement along the northwest and northeast trending faults occurs in combination with the formation of small kings in the main faults. Reverse movement during low temperature brittle ductile deformation is also evident in this area. So if you just quickly look at the mineralization events, and Damien and Andrew has explained this in much more detail, we know that gold, copper, and bismuth was deposited into these ironstones. And these ironstones seems to be stratigraphically related to already hematite-rich shales that's in the Warramunga Formation. These ironstones is hydrothermally altered portions of this shales, and it's commonly ellipsoidal in shape and flattened in the direction of strike. The mineralization precipitated in these ironstones as the mineralized fluids sort of was pumped through these ironstones through a association of the reduction due to the ironstones reduction in oxygen, and then also through the drop in pressure and also the pH constraints. Chloride-rich pipes extends below and around these ironstones, as Damien has shown very nicely as well, but they're not, you know, going over a vast area. It's actually quite closely related to these ironstones. And then dating, as we heard, placed this mineralization roughly about, I'm just going to call it 1800, 1825 sort of time frame. So the Crown Pillar failure. This event occurred early in the morning of the 11th of August, 1967. And, you know, coincidentally, there was no injury that happened during this event. The collapse formed over an area or over a stope, which was mined up to 25 meters below surface. And the diameter of the final sinkhole reached up to 50 meters. And as I said, in this failure zone, uh, there was an office building, mill, vehicle that all collapsed into the zone. This zone was then excavated, as I mentioned, and stockpiled next to the plant. And then everything continued from there as an open cast mine. So why was nobody injured? And there we look at, you know, signs of what's going to happen. When's the failure going to occur? And there's a lot of studies geotechnically that will illustrate that there's various signs that starts happening up to years, months before a collapse would happen. And these would include ground condition changes or even failure zones or ground movements opening up. More closely related to the failure zones. So as time comes by, you'll actually see an opening of failure zones or fractures, and then also crumbling of underground support that would have been prevalent at the time. So that was enough warning for the people to actually extract from the zone and uh, yeah, then in the early mornings, the failure occurred. So let's look at the crown pillar stockpile. This is the excavated material now. You can see a photo there as well. And it's notoriously difficult to quantify a content of a stockpile because it's not controlled by geological events. It's human made, it's excavated out, loaded on a truck, and dumped. So the easiest thing is to quantify the tons, and that we can do these days quite easily with drone-based technology. It's quick, it's fast, very accurate as well, almost in real time. But the stockpile grade uh, determination needed to satisfy PSG's formula and also limit the sampling error just to be sure that we, we know what's happening there. And how that was done was first of all by doing an RC drilling bit over the stockpile, which was followed up by sonic drilling. So sonic drilling is actually a preferred method for a deposit like this because it doesn't require any compressed air or any fluids. It's actually designed to drill into alluvials or glaciers, etc. So it's a very good drilling technique. In total, about 79 drill holes was drilled into the CPS. And then also 6,000 ton bulk sample was excavated from this material, which allowed for homogenization of it, as well as additional assaying, bulk density measurements, which was very difficult doing it from RC or sonic drillers, as well as particle size distribution, and also the quantification of where the gold mineralization is sitting, in which particle size does it occur. So is there an ability to upscale the grade through the screening program? And then also, obviously, to do metallurgical test work. And all of this combined resulted in a mineral resource of about 1.3 million tons, 1.5 grams per ton on surface, already excavated, already blasted as such. So that's just amazing. So continuing with that, it's a rich history of mining in the Tennant Creek Goldfield, almost 100 years of mining. And at the time of cessation of mining, which ranged between 1985 and early 2000s, the US dollar gold price sort of varied between $250 to $500. And we see today, the gold price roughly at about 5,000 Aussie dollars or 3,000 US dollars, if I checked this morning. Um, really marks a massive change in the macroeconomic conditions. And we really need to evaluate what can be done differently to what was missed previously. So previously, uneconomical mineralization at a gold price of 250 or $500 now at this gold price really needs to be reinvestigated. And I think that's what everybody at this conference has been talking about. It's massively different economic conditions than what there was previously. TCMG then, along with the Emerson team, evaluated all of the historical information that existed. And I think that is the rich portion of this field and probably of most of the deposits in the territory. It's got a rich history of exploration, and we need to evaluate how do we make use of these data sets and not reinvent the wheel. So PCMG then digitized, collated, and made all of this data relevant again, used it for geological modeling and resource estimation. While doing that, obviously you need to do validation to comply with the reporting codes as well. So twinning of some of the historical holes occurred, making sure that we understand the quality control and quality assurance procedures that was followed historically, which most of the companies actually did to the best industry standards during their time of operation. And this just aided the company in fast tracking to a mineral resource that was reported. From there, the models were subjected to pit and underground optimizations, as well as metallurgical test works, which also allowed upgrading of that mineral resource then to a very fast upgrade into an ore reserve or Pan-African report against the SAMREC code, so we call it a mineral reserve. So you sit there within a 3-year time frame from concept to a maiden reserve reported again after a hiatus of mining of about 30 years. This resulted in an initial life of mine of 80 years already, just based on historical and brownfields exploration in the current economic conditions. So, going with the trend that TCMG started with, trying to leapfrog and fast track this project, they acquired a already existing CIL gold plant in Cloncurry and commenced with the relocation thereof in May 2024. So this gold plant consists of everything you need to process for gold from the milling circuit through gravity gold recovery, CIL circuit, elution, gold room, everything is available. And it was relocated and constructed in a period of about 12 months. And that is also unheard of. If you have to build a new plant, it's going to take you about 2.5 to 3 years to procure everything, get everything going. Um, I mean, just the amount of value added by having an existing gold plant with the drawings and everything being there, that's amazing. And this, as I mentioned, is the largest gold plant to have ever been constructed at 840,000 tons a year capacity, which just further expand on that opportunity of previously uneconomical material because you've got economies of scale. The future work that TCMG is looking at doing, obviously, we all believe in the greenfields exploration potential of the Tennant Creek Goldfield, and that is really where we want to focus on. We've looked at the brownfields. We do understand we can extend the mineral resources and reserves around that. The key is lying in finding untapped ore bodies. And with that, we'll make use of new technologies, faster acquisition of data, almost real-time acquisition of data, and then using multiple geophysical techniques to quickly look a bit deeper. We've seen now from Adam, drilling about 60 meters below surface. I think in total about less than 8% of the borers intersected ore up to about 150 meters or below 150 meters. And maybe another point about Pan African is in South Africa, our mines goes down to 2.5 kilometers below surface. So we're really interested in what's happening at depth and what can we extract from there. Then also just looking at the ultra fine soil fraction and how we can target sort of unexposed mineralization from there. And you can see in the box plot below that if you look at the ultra fine swirls, it really gives you bigger and better spectrum of identification of possible targets existing. And then I think I don't know if it's been put out in the market, but we've commenced with the feasibility study for the copper gold circuit of the Warrego deposit, which was presented on a bit earlier, which is probably the largest gold copper deposits mined in the Tennant Creek Goldfield. Thank you very much.